Hello, welcome to another video. We're gonna talk about C programming, specifically the const and const pointers and etc. So we will see what it means to use the syntax and some of the pitfalls that may happen. So I wrote this program very small to save time and be able to focus on the main idea of this video. So I have main.c, this is my main function, and I have the header file which defines these functions. It's included here, and I have the functions in the C file over here. So say you do actually use a header file and you find out that you have these prototypes. So the first one is a type pointer constant variable. So the constant is always applied to whatever is before it. In this case, the constant is the pointer. If the const was at the beginning, something like this, const int, there's nothing before it, technically it should be, I switched the buffer, 1 second. Technically it should be something like this. So it's always cleaner to write the const after what you intend to be the constant. For now we'll keep it like this to demonstrate. So this is what I was talking about. This is equivalent to the const being in front of the int. In this case, the const is the int, not the pointer. It means that the pointer is pointing to a constant int. That means I cannot change what the pointer is pointing to. Now you can have something that's more complicated, like a type pointer const. If you understand these 4 examples, by the way, you can chain as much as you want. You can have as many pointers as you want. So in this case, var is a constant pointer to a pointer to an int. Now your head may hurt, but what this is saying is I cannot change the first pointer, which is this guy, but I can change what this guy is pointing to. And in the examples, hopefully it becomes clearer what that means. Now we have this case, var is a pointer to a constant pointer to an int, and we can have basically const after everything, constant pointer to a constant pointer to a constant int. Now let's see what this means. So I have an int x equals 1, and we will try to modify this guy in these functions. Now if I use a library, and it's a legit library I would say, and I find something with this declaration, this is a promise from the developers of the library. It's a promise that they're not going to change the pointer. This case is not very useful, and I will show you why in a second, but that's the promise. So we're printing the address of x, and we're printing the value of x before calling the function and after. Now say you try to do this and you try to change, so var is a pointer, so just var, that's the address. We're not allowed to change it because it's read only. And if I save and I compile, we're gonna get an error, which is this guy. So we're telling the compiler, hey, do not allow me to change this. This is supposed to be constant. But you can trick it. So if I create a double pointer and the double pointer is pointing to the address of var, then I can then I can change this guy. But hey, this is meaningless because this guy trick, or also the var variable, they're on the local stack of the function. So by changing that, it doesn't do anything. I can, however, change what's inside the variable. So that's why this type of function is meaningless in this case. It doesn't make sense to put const pointer type because I'm not doing anything. If I change var locally, it doesn't change anything for me. It's meaningless. There's no good application for it, at least for single pointers. So let me execute the example now, and let me just make sure that I have an error. Oh, I did not comment it out. So var, where's my var? That's the var. Did I save? Let me save. And that's inside my type pointer const 911, and yeah, so there you go. I forgot to save before, so here's the file. So if I do have warnings, and basically it's warning me that I'm doing some weird tricks. I'm assigning to pointers and ints. This is an int, not a long or whatever size t. So we can ignore these for now. But if I run the function, I start with x being 1, and then it's set to 10. Therefore, this guy is okay in this case. I'm changing what's inside that parameter. Now, second type. If I read this in a library function, it's a promise that what's inside the pointer is not going to change. And this is important. This is really important. So I'm not allowed to go and change like this guy, set the value to 3. It won't let me, which is good. However, it's possible to either accidentally or deliberately create a double pointer which points to this address, and this guy is not const, and I can change what's inside x to 4, although it was constant. See? It was 10 from the previous call, now it's 4. What I'm trying to say here is this is more or less tells you how it's intended to be used, and if I ever see this, it's a bug. It's not supposed to do that in any way. Don't tell anyone, convince you that, yeah, it's okay. This is bad design. Now the third example, we move to double pointers. What's const here is the address of var is const. This becomes something like the first case, where if I change the address of var, although I cannot do it directly, but even if I change it, it's meaningless because this address var is on the local stack of the function. So actually it was this guy. So if I do this though, I can, but there's a problem. The problem is the star var now is pointing to a memory address, and I'm changing it deliberately. Why would you do that? Nowhere in this function it's saying that you should not be doing that. You could, but just the fact that this kind of prototype exists, it's a sign of something like the intention is not communicated properly here. You should never see this type of, it doesn't make much sense. So let me comment this out again. Otherwise I have illegal memory address. Now the fourth one, what's constant here is whatever that pointer is pointing to, which is another pointer to an int. So this guy is the constant now. So if I try to change star var, which actually is a memory address, and in our case, look what I've done here. I created a pointer y, which has the address of x. So y has the address of x, but the address of y becomes the double pointer. I dereference it twice. In this case, what's constant here is y. So this guy is guaranteeing that if I call this function, the address of y after the function call will still be whatever it was set to, but the value of it can change. Nowhere it's telling me you cannot change that. And we change it. Let me comment this out. We change it through this guy, and it's perfectly legal. I don't need this guy actually. So it's perfectly legal to go inside. So I'm changing this guy here is changing the int, which is not constant. Now again, I can do tricks. I can create a double pointer or a single. I can do something like this guy, yes, a double pointer to modify y, but that would be should be treated as either a bug or a bad design. It's a sign of trouble. Now in this prototype function, I'm saying the address of var cannot change, which is pretty much useless. I'm saying the first parameter or the first pointer, yeah, that's the address of whatever gets passed, which is y, is constant, which is var actually, not the address of var. This guy is also constant, which is y, and this guy is what's inside y, if we call it that way. So basically here I cannot change var, I cannot change star var, and I cannot change double star or double pointer to var. However, since this is a double pointer, I can create a triple pointer and set it to the address of var, and I can change that, and you will see that I managed to change the variable, although they were passed as const. So, does that make the language bad? No, that makes the programmer bad. The language is so powerful, it allows you to do whatever you want, and it's up to the programmer to be a good programmer, a professional programmer, to stick to the contract that they're making. I hope this made it clearer on how to approach and or how to interpret the function prototypes and what's meant by them and how to identify problems. Thank you for watching.